Hi and Assalamualaikum. My name is Muhammad Zarif Mirza bin Muhammad Zuruzain. My metric number is 203727. So today our group will representing our lifelong learning assignment. So our group will discussing about rice grain as our material. Okay, firstly in our table content there includes introduction, the explanation about properties and their methods, and also the conclusion. So I will cover the introduction part. It seems that rice is our staple food. How deep do you know about rice? So, what is rice? Rice, or scientific name, is edible starchy cereal grain and the grass plant family Poaceae by which it is produced. There are over 120,000 different varieties of rice, including black and red strains as well as white ones. The cultivated rice plant is annual grass and grows to about 1.2 meters, 4 feet in height. The leaves are long and flattened and are borne on hollow stems. The harvested rice kernel, known as paddy or rough rice, is enclosed by the hull or husk. Brown rice, remove only the husk. White rice, milled to remove the bran as well. Rice is the world's #1 the most important food crop and dietary staple ahead of wheat, corn and bananas. In Asia, more than 2 billion people rely on rice for 60 to 70% of their calories. Besides having some general knowledge about rice, here I want to introduce about main points in our discussion, which is properties of the material. So what are the properties? There are 4 properties that we choose, which are mechanical properties, physical properties, optical properties, and thermophysical properties. So mechanical properties is test of strength and energy needed for the destruction of rice grains. Physical properties is the knowledge of physical and engineering properties of grain materials. Otherwise, optical properties is the study of surface property and its effect on reflectance of light. Thermophysical is the thermal properties are determined at different moisture contents and temperature. Next, here is the list of methods that being used in the selected properties, such as UV visible spectroscopy, which are being used in optical properties, the compression test, and 3-point bending test, which are being used in the thermophysical properties, and other several methods. So for further explanation regarding towards the properties and method used, it will be presented by my group members. So I think that's all for me. Thank you.
Hi and Assalamualaikum. My name is Nur Ain binti Rusli and my metric number is 203726. I will explain about the mechanical properties of rice grain. The keyword that I use to find these properties is mechanical properties of rice grain. I have searched about 8 until 10 times about these properties to find the suitable reference for these mechanical properties. From Saka et al. 2017, mechanical properties are important and need to be identified and then be quantified in designing of agriculture processing machinery. For example, in industrial drying of rice grain, a relevant contribution to produce quality rice is given by increased bending strength 35.7 megapascal in rice grain from fixed bed drying using temperature of 40 until 60 degrees Celsius. The assessment of tensile strength and bending strength are two indicators that are well related to HRY, which is head rise yield, compared to compressive strength. It is difficult to set up tensile tests since it requires a complicated preparation of specimen due to the irregular shape of rice grain. In contrast, bending test is simple and maximum bending force has been proven to hold a good correlation with HRY. Therefore, the 3-point bending test is chosen as the method to accomplish the test. 3-point bending test. The 3-point bending test were used to determine selected mechanical properties of 100 individual rice grain, namely, first, bending strength, Second, Appren-Young's modulus of elasticity. Third, fracture energy. And this is the equation that we use in the test. Bending strength. Sucker et al. 2017 proposed that the mean values of bending strength shown in the figure indicated the differences in bending strength of rice kernel among the drying methods. The average bending strength was ranged from 28.6 to 31.8 megapascal. Analysis of variance in ANOVA revealed that the industrial drying methods were significantly at P less than or equal to 0.05 effective in developing the bending strength of rice grain. Appren-Young's modulus of elasticity. Sucker et al. 2017. The average value of Appren-Young's modulus of elasticity of rice kernel from different drying methods was ranged from 204.5 to 222.4 megapascal. This increased value of Young's modulus of elasticity did not vary significantly at P less than or equal to 0.05 with respect to the drying methods. It is clearly perceived that the effect of drying method while paddy dried with higher and lower temperature on Appren modulus of elasticity was not so prominent, because modulus of elasticity measures the load deformation behavior of a material. Thus, the results indicated that altered drying temperature of different industrial drying methods did not affect grain deformation due to load applied for breaking the grains, while this effect was inconclusive. The effect of on fracture energy in rice grain noticed significant P less than or equal to 0.05 differences with industrial drying methods compared to control drying. The mean value of fracture energy as function of drying methods are plotted in the figure. Fracture energy of rice grain during industrial drying was slightly higher than that dried by ambient air drying. However, fracture energy among the industrial drying methods did not vary significantly as viewed in the figure, while all the drying methods got A or AB letters. Fracture energy is an indicator of grain turnover, which indicates that the higher the fracture energy, the more difficult it is to break the material. Partial gelatinization of the starch on the surface of the grains occurred during drying at higher temperature. The differences between compression test and 3-point bending test is 3-point bending test is suitable in the drying industrial of rice grain. Meanwhile, compression test is used to test the strength of the rice grain. Method used to measure mechanical properties. This is the Instron 5966 testing machine to use in the compression test. Meanwhile, this is the position of the rice grain during the static compression test. Procedures in conducting compression tests. Firstly, a static compression test was carried out on an Instron 5966 testing machine to determine the force needed to break the grain. A static compression test was carried out for 100 grains of the species Oryza sativa L, a long grain variety with a stabilized humidity equal to 30% plus minus 0.1%. Samples of 100 individual rice grains were prepared and described by numbers. The samples were placed in the machine in a horizontal orientation in such a way that the dimension A1 and A2 were the large axis and small axis of cross-sectional areas of the grain subjected to the load. The load speed was 2 mm per minute. This is the rice grain prepared for compression test. And this is the dimension for the rice grain. Equation used in this method is the grain density equation, and this is the volume determined on the basis of density Vp. This is the grain volume equation, and this is the grain density equation. This is also the equation used in the compression test. The result for the compression test. Figure 9 presents a graph showing the characteristic of rice grain cracks during a compression test. Based on the presented curve, it can be stated that for each grain, the crack proceeded differently. This is caused by differences in internal structure between each grain, which is characteristic for biomaterial. However, you can see from this graph, F min is the first point for the rice grain to crack, and the F max is point correspond to the force causing the breakdown of the grain to the smaller fracture. Compression test is suitable to categorize as increase of knowledgement or technology for lifelong learning because there are many equations that were used in just one test to get the result.
And now I will present circle properties. Circle properties are properties that can be measured or observed without changing the chemical nature of the substance. Circle properties are used to observe and describe matter. The samples were cleaned manually to ensure all foreign materials such as dirt, stones, chaff, immature and broken seed are removed. There are commonly used tools for testing physical properties. Paddy and brown rice grains was randomly selected from each culture and their principal dimension, length, width, and thickness was measured using Pennsylvania clock. The equivalent diameter in millimeter, considering a prolate linear rate shape for paddy and brown rice were defined by using expression as described under this. The sphere is defined as the greater of the surface area of the space having the same value as that of grain to the surface area of grain was determined using expression as described. Grain volume and the surface area of paddy and brown rice was calculated by using different expressions. The aspect rate was determined by using following formula. The true density was determined by liquid displacement method. Coulomb's symbol of about 25 grams was measured in water in measuring a third having a race of 0.1 milliliter. The increase in volume due to sample was not as true value of sample, which was used to determine the true density of the sample. The true density equates mass of individual seed except value. Porosity was defined as the ratio of intercellular void space volume and the volume of the bulk grain. The angle of repose was determined by using an empty cylindrical mold of 15 millimeter diameter and 25 millimeter height. The cylinder was placed at the center of galvanized any plate filled with rice grains and raised gradually until it forms a cone of grain. The height of the cones was measured and the filling angle of repose was collected by following relationship, where H and D represents height and diameter of cones respectively. Rockwell Handler's machine was used to determine the hardness of the seed. The upper part of the instrument slot was screwed downward to press the samples. The reading on the hardness tester when first sound was heard indicates its hardness. The hardness value divided by contact area gives the contact hardness number. The experiment was replicated 3 times for each variety in horizontal and vertical direction. A recording compressive voice gauge was used to obtain the compressive strength of the seeds. The slows was screwed to compress the seeds placed between them. The counter reading was taken immediately. Once the first quacking sound was heard, the experiment was replaced 3 times for each variety in horizontal and vertical direction to obtain the average reading.
My name is Nurul Nazira binti Yasir. My metric number is 203725. I will explain about the optical properties of rice. So what is optical property? Optical property are usually used to determine the quality of food, and color is the main optical property in evaluating quality. So what is color? Color is a selective absorption of different amount of wavelength within the visible region, and it usually determines the acceptance of food by the consumer. For example, we as a consumer, if we want to buy a sweet apple, we will definitely choose an apple that is red in color. And color has 5 order system, which are Munsell color system, CIE color system, CIE lab color spaces, Hunter lab color space, and color difference. Let's move on to the optical properties of rice. A normal rice grain usually exists in white, brown, black, and red in color. In the left-hand side of the slide, you can see that this is a graph of reflectance spectra versus wavelength that I got from Bordoloi research. And the normal rice grain, which are in red line, has a steady rise in reflectance of light, and there are no peak being observed in the normal rice grain. And normal rice grain is in the second place of reflectance of light. Rice has lower surface roughness and thus it has higher reflectance. This is because surface roughness plays an important role in optical properties. This is the scanning electron microscopy image of normal rice grain and puff rice at different magnification. As you can see in the normal rice, it has a lower surface roughness, And in the puff rice, it has a higher surface roughness. So that is why, as I mentioned before, a normal rice grain has a higher reflectance of light than a puff rice grain because the surface roughness influences the reflectance of light. So what are the techniques that are used to measure optical properties? Today, I will explain about the UV visible spectroscopy. This UV visible spectroscopy is an absorption spectroscopy technique, and it relies on a sample containing species that absorb light in ultraviolet to visible range. For ultraviolet wavelength, it is usually between 4 to 400 Newton meter, and for visible wavelength, it is usually between 400 to 700 Newton meter. And from this technique, we can measure the amount of radiation absorbed for each wavelength. And we can also obtain the spectrum by plotting a graph of the amount of radiation absorbed versus the different type of wavelength. And this is the schematic diagram of the UV visible spectroscopy. A UV visible spectroscopy apply Beer's law, and we can calculate absorbance, transmittance, and we can also see the relationship between transmittance and absorbance. We can calculate absorbance by multiplying the absorption coefficient with concentration and path length. The absorbance and absorption coefficient can be calculated by using spectrophotometer. Next, the transmittance. So what is the transmittance? Transmittance is the ratio of intensity of transmitted light to the intensity of incident light. And this equation right here shows the relationship between transmittance and absorbance. Last but not least, let's talk about the advantages of UV visible spectroscopy. This UV spectroscopy are widely used to determine the quality of fruits and vegetables and also other crops because it has a great versatility, a high sample turnover, and it is easy to handle. This UV visible spectroscopy is a great method to detect maturity or defects. For example, work from Torresilla and collaborator utilized the UV visible spectroscopy to quantify the adulteration of extra virgin olive oil with refined olive oil and olive pomace oil. This technique was capable of estimating the adulteration agent concentration with a mean square error of less than 1%. From this example, it is proven that this UV visible spectroscopy is a great technique to detect maturity. That's all from me. Thank you.
Now I will present about the thermophysical property of rice grain. My name is Ong Ting Yi. My matrix number is 203729. Now I will list the thermophysical property and the equipment used. For specific heat capacity, micro DSC3 is used. For thermal conductivity, Pro FBA4371 is used. For bulk thermal diffusivity is calculated through the calculation. For specific heat capacity, micro DSC3 is used. The figure is shown on the right-hand side. The DSC consists a calorie block and a controller. The calorie block is used to set the temperature, while the controller is used to amplification the temperature coming for the calorimeter. For thermal conductivity, probe FBA4371 is used. The figure is shown on the left-hand side on the slide. The probe is fed a constant heat flow into a test cylinder considered a sample, which is rice grain. The bulk thermal conductivity is then provided directly by the equipment. For thermal diffusivity, it is calculated using the value of bulk thermal conductivity, specific heat, and bulk density. This is the formula of the thermal diffusivity. This is the graph of specific heat capacity of rice grain. We can see that different moist content of rice grain will have different specific heat capacity. When the heat capacity increases with the increase of moist content and temperature. Specific heat of rice grain can be predicted by the expression with moist content and the temperature. This is the equation. The graph below shows the thermal conductivity of rice grain. You can see from the graph the thermal conductivity of rice grain will increase with both moisture content and temperature. The following expression was found to calculate the thermal conductivity of rice grain use moisture content and temperature. This is the equation. This is the graph of thermal diffusivity of rice grain. We use two temperatures to test the thermal diffusivity. The thermal diffusivity is in the range from 7.515 times 10 power negative F to 9.86 times 10 power negative X for moisture content from 0 to 14%. Thermal diffusivity increases for low moisture content level and decreases as the moisture content increases. Now I'll explain further for the specific heat capacity of rice grain. The specific heat of rice grain is determined by DSC at temperature 3 to 41 degrees Celsius is 1.1502 to 2.1464 kilojoule per kilogram degrees Celsius. For thermal conductivity at moisture content from 825 to 25.80%, the bulk thermal conductivity is from 0.075 to 0.1472 watt per meter degree Celsius. For thermal diffusivity, when the probes and capillaries is filled with air is gradually displaced by absorbed water, heat is released by water absorption, and the thermal diffusivity will increase.
Hi, my name is Nofazina binti Nur Ashab. My metric number is 2037228. And I will do the conclusion and summarizing all the properties that have we discussed before. So this is all properties and method and technique that we use to obtain the all properties. So rice is the major source of food in the world. The grain rice quality is more complex than other grain since it was served as a staple food. Quality of the rice grain was very important and we can determine the quality based on its properties. There are 4 types of property we choose, which are optical properties, thermophysical properties, physical properties, and mechanical properties. To measure an optical properties, we use UV visible spectroscopy device, where it is usually used to measure UV absorbance spectrum. Spectroscopic methods have been used for a long time to evaluate the quality of agricultural products, especially food. The absorption of UV is based on Lambert-Weir's law. This method is depend on the length of radiation wave, the characteristic extension coefficient, and length of the radiation wave. Next, for thermophysical properties, there are 3 properties which are specific heat, bulk thermal conductivity, and bulk thermal diffusivity, where specific heat was determined by micro DST3, bulk thermal diffusivity was determined based on calculation, and bulk thermal conductivity by probe FPA 4371 method. All these properties have been determined at different moisture content and temperature, where moisture content will give greatest effect on specific heat and bulk thermal conductivity, while temperature only gives smaller effects. Micro DST3 was successfully used and suitable for measuring specific heat of rice grain in the whole range of temperature involving in the cooling and storage processes. The advantages of using micro DST3 are we can get multiple data from a single thermogram and a very small sample can yield accurate result. The advantages of using micro DST3 are we can get multiple data from a single thermogram and a very small sample can yield accurate result. The probe FPA 4137 was used to determine the thermal conductivity, while for thermal diffusivity, we can measure it directly using formulas that have values of specific heat, thermal conductivity, and bulk density. Moisture content do affect a bulk thermal conductivity based on Wharton et al. And Morita and Singh. They proposed that linear relationship was used to explain the increase of thermal conductivity with moisture content. Third property that we discussed was physical properties, which were bulk density, true density, moisture content, porosity, and the hardness of rice grain. Liquid displacement method also usually used to determine volume of the rice grain. By calculating volume and mass of a sample, we can determine the bulk density. The difficulty determining the volume of a grain is when the samples are in a non-destruction manner and on a large of grain, which might be difficult to calculate the density. Other than that, Rockwell hardness machine and compressive strength force curves both were used to determine the hardness of rice grain and to obtain compressive force of seed. The Rockwell hardness test method was commonly used for hardness tests of rice grain and more accurate than other types of hardness testing. Last property is mechanical properties, which can always be determined by using compression test and 3-point bending test. By using 3-point bending test, the low loading speed can minimize the stored elastic energy, while compression test was usually performed for brittle material, where rice grain can be considered as a fragile material due to the internal structure that fragile material like compressive lag can be determined. In conclusion, these all properties that have been discussed are very important for proper storage procedure, dimensioning, manufacturing, and operating in harvesting and processing operation of rice grain. So that's all from me. Thank you.